Welcome back. This is the last video on functions, and it covers an important piece of the puzzle that's been mostly left out so far: return values. Think back for a second to when you learned how to determine the type of a variable. Now, print is always followed by some value that is printable. In this example, the word print is followed by a function call. So how can type act as both a function call and a value in this example? Type is a special kind of function, a function that has a return value. This basically means that after executing it, the Python interpreter replaces it with a value. This is sort of like how the Python interpreter replaces mathematical expressions with their values. When you write a function, you have the option of making it return a value. Here's an example of a function that does just that and nothing more. When the function is called, it will run, and then the call will be replaced by the return value. After getANumber is done running, the call, highlighted in green, will be replaced by 10. This sets the value of x to 10. Here's a function that has both a parameter and a return value. In this case, the return value will always be one more than the parameter's value. You can actually give add1 5 directly to print instead of using a variable as an intermediary. The call to add1 5 will be replaced by the number 6, which is then given to print and displayed on the screen. You can do this multiple times, and the return value will be different if the argument is different. Let's step through this program. The program starts after the function definition, though the interpreter makes a note of what add1 means. In order to figure out what needs to be printed, the interpreter dives into the instructions for add1 and keeps track of where it left off. The parameter num is given the value 5 this time. That makes the return value 6. Now, print has something that it understands, the number 6. The same process happens for each of the other two calls to add1. The interpreter jumps up to the instructions for add1, sets num to 6 this time, making the return value 7, and 7 is what replaces this call to add1. Then the interpreter moves on to the last print, jumps up to add1, sets num to 7, returns the value 8, and 8 replaces the call to add1. Now let's trace through this program, which features a function calling another function. Once again, we start with the first thing that isn't a function definition. The interpreter jumps to my function, and the argument, 12, is assigned to x. In order to evaluate the return statement here, the interpreter has to jump to add2, which has its own independent parameter called x, whose value in this case is also 12. It came from the value of the parameter x down below in my function. This return statement is pretty easy to evaluate. We add 2 to x, and the result is 14. The interpreter is now finished with add2. The call to add2 gets replaced by the return value, 14. Now the interpreter has to evaluate this call to multiply by 3 here. So it jumps up to multiply by 3, and this function's parameter, x, gets the value 12. I want to point out again that even though all the parameters are called x here, they are actually effectively different variables which could have different values. This return statement simply involves multiplying x by 3, so the result is 36. 36 is what replaces the call to multiply by 3, and now the interpreter can fully evaluate this return statement. It is simply the sum of 14 and 36, or 50. And 50 is what replaces the call to my function and what ultimately gets printed. That was a lot of work for one small Python program. Of course, Python does all this in the blink of an eye. Let's try to write a function called negate that takes a number and just returns the negative of that number. I'm going to do it incorrectly first. I'm going to say def negate, and it's going to take a parameter called x, and instead of returning anything, it's just going to print negative x. Now, if I call negate on 5, this should print negative 5, but this is not a function that has a return value. It's just a function that does something. It just prints something. If I try to print this function call, what will happen is first, the function will run, which will print negative 5, and then I'll print the result of negate of 5. Now, if you try to print a function call when the function doesn't have a return value, what you'll see is this thing none, and that means there was no value. None is basically the absence of a value in Python. Now, what I can do instead of printing negative x is I can say return negative x, and now what will happen is this call to negate will execute. The return value will be negative x. This will get replaced by negative 5, and that's what will be given to print. So it should just print negative 5. Let's test it out. And there it is. Now let's add a comment. This function takes the negative of its parameter and returns.